Hello. I want to talk about another question that was asked in my computer aided engineering class, and that was to automate some of the simulations when something is changing and you want to reach a goal. For instance, in the simple static analysis where it's a cantilevered beam fixed at one end and a load of 1500 is applied, if at the moment we accept all of the stress distribution results, if you watch my previous video, you know we have some problems on these corners. But other than that, let's say for the moment, just for the sake of discussing this new topic, we accept this minimum safety factor of 50.51. Okay, so let's say this is really the minimum safety factor we have. Now, I want to know how much I should reduce this load of 1800 such that this minimum safety factor goes to, let's say, 1.25 or something, right? So I have some goal. The goal is to not drop below 1.25 of safety factor. My variable is the load here, not a dimension. If you watch my video on design study, what I explained in that video was changing dimensions, right? So that your design basically works. And the goal was, let's say, to minimize the mass or something, huh? So how about here? The goal is to reduce that load up to some value that the safety factor is still above 1.25, but let's say you still want to apply the maximum load that you can, correct? Because you want it to go down less than 1500, but as soon as this minimum safety factor passes 1.25, then you want to stop. You don't want to go further down. So you want this beam to tolerate the maximum load it can as long as safety factor is above 1.25. Can you do that as a design study, and can you automate it? Because if you don't, then I have to go down, let's say, to 1200, redo the simulation, come and look at this. Well, now maybe it's 0.8. I keep going down until this passes 1.25. And when it does, it doesn't exactly land at 1.25. It might go to 1.4. So now you have to come back and increase the load again and do several trials and error until you get very close, right? So you have to rerun this analysis by changing this load every time. Could you automate that? The answer is yes. And you can do it with the design study. So let me show you how. You go here to new study after this static one, and then you do a design study. Okay? And you go here, and then here you have to define your variable. So look here, you go here and say add a parameter. And this is the one that I want, and I want to delete it so I can redo it for you so you can see it. Right? So by default, it's a model dimension, but if you click here, it allows you to pick on other things like material, motion, global variable, or simulation. So here I go to simulation, and it says, what is it in the simulation that you want? Go to the simulation tree and pick it. So here I go to my simulation, and what is it? That's this force here. So I click in this window, and then I click on what? On this force. You see? So now that guy is there, the unit is Newton, the value will automatically be updated to 1500. It says give it a name, I call it load, right? And I can apply that, okay? So now I have what? I have my variable as load. Now, what range do you want to change it to? Right now it's 1500, so let's say I want to go anywhere from 200 to 1600 with the step size of 200. Okay, so I want to go in that region. And then what is the constraint here? So here you see I have already added it, but let's say I want to add a sensor, and it says what is it? I go to my simulations and I look at the safety factor, and I look at the model minimum, and I create that, right? And you see here, I want it to be greater than what? Greater than 1.25, right? And my data is coming from static 1. What is my goal? My goal is to make that force as large as possible, or the stress as large as possible. So here I go and add a sensor. And again, this time I go to my simulation data and stress maximum model, right? So I want to maximize the stress, not minimize, while my safety factor is still above 1.25, and I want to go from 200, every 200 increment, all the way to 1600. Okay, once everything is set, you click on the run. Here I did it already. So if we go to the result review, you see there are 8 scenarios. It's a brute force search. It's going to look at all of them. And then you can see that the optimal solution is 800 Newton. Scenario 4, where the safety factor minimum is still above 1.25. You see, once it goes to 1000, it drops below. And you still have the maximum stress between these 4 scenarios, for which all of them, the safety factor min is above 1.25. This one has the highest stress, which means the maximum load. So you can go as, you need to go around 800. It's not exactly, because you see here it jumps over 1.25. And it should be between 800 to 1000 is where you need to have your maximum load, so you keep the minimum safety factor 1.25. If you want to get closer results, change the step size. Okay, so instead of 200, go 100, go 50. Of course, it needs to evaluate a bunch of more scenarios. It takes more time, but you can get closer to the maximum load that you can apply. But this is how you automate this. Hopefully it was useful to you. I'll see you in the next video. Thank you.